Hi everyone, my name is Shruti. In this video, we're going to understand what are the challenges in the IT environment that container technology solved. So let's begin with understanding what is container and why containers. Let's start with why. Why did container technology come in place and what it is trying to solve? Previously, if you need to run application, you need hardware, that is storage memory CPU, an operating system which controls how the application uses the hardware resources, and on top of that we have the application running. Say now you want to run the application not in a Windows but in a Linux environment. Then you need to purchase the entire hardware stack to run the application. And each application has its own library and dependencies specific to certain version. So say you have application 1 and application 2. And application 2 needs a different version of the same library. Then you need to purchase again the entire hardware stack, a separate OS configuration, and then you can run your application 2 on it. And this is called as monolithic architecture. This is taking more time to deliver the end result what we need. Say you want to make changes in the code, if there's a bug, you need to retest this again, compile again, and this is going to take more cycle. This ultimately leads to underutilization of the infrastructure. As you can see, the application may not need the entire underlying hardware resources. And this problem is solved by virtualization technology. In virtualization technology, we have the hardware, the operating system, the hypervisor, and this is also known as virtual machine manager. It is the software that shares the underlying resources, that is the storage, memory, CPU, to multiple virtual machines. The diagram here is a type 2 hypervisor. In type 1 hypervisor or a bare metal hypervisor, where the hypervisor directly runs on top of the hardware, bypassing the need of an operating system. So the hypervisor is configuring the virtual machines, and each virtual machine has its own OS called the guest OS, binary and library code to run the program, and then on top of that we have the applications running. These VMs are isolated and does not affect the host OS, and you can create VMs as and when needed. So say an OS crashes, your VM is not performing as you want, so you can just create another VM and then the application is up and running. And as you can see, the virtualization technology has reduced the need for an additional hardware. You can run multiple operating systems, and this lowers the maintenance cost, the licensing cost, the power and cooling cost. And this looks great, right? So then what are the challenges with virtualization? So as you can see, each guest OS is a full OS, and this takes resources in gigabits of size. So say your VM, your application must be just in MB in size, but you need to spin up a virtual machine in gigabits of size, and this is why it's called heavyweight. As VMs are running on a full-fledged OS, every time you want to start a VM, restart, shut down, it involves running a full OS cycle and booting procedure. And this process takes minutes. And if you're talking in terms of agile and DevOps, say you have application, you have some enhancement in application, or there is a bug, then the application needs to be deployed in a separate VM, and this will take lot of time to configure because you need to boot the OS, configure the OS, and this takes in minutes. And if you talk in terms of agile teams, these releases are very quite often, and it takes a lot of time in order to get a new application to be released. So this challenges were solved by containerization. To give a bit context on the history of container, the first container was developed by Google, known as LXC, and We use containers every day, whether it's our Google engine, YouTube, the Gmail, all are based on container technology. Here we have the hardware, the OS. In this, we are replacing the hypervisor with container runtime or containerization engine. The container runtime helps to create container image. This container image consists of the binary libraries, the networking, the OS configuration, whatever is required to run the application. Now you can see the container runtime helps to bypass the need of an operating system per application, and that's why it's called lightweight. It stores the machine OS, the system kernel, and it does not require OS per application. And this reduces, uh, or in other words, you can say this increases higher efficiency of server, reduces the number of server resources to be used, and reduces the licensing cost as you do not require separate OS, and a full-fledged VM would take gigabytes of size, and container will take just a MB in size as much as an application which you might be running. You can start and stop a container as and when you want, and in case of a VM, it would take a lot of time as we see to boot up. In this video, we understood what container technology has solved. But we see in data centers, they use both container technology as well as virtualization. So what are the benefits when we use both and why we use both the technology? We'll see that in our next video. Thank you.